Episode 1, How It Started, Climate Change. Hi, my name is William Taggart, and I want to talk to you about my book, Fixing America. I want to start you off with two quotes. Society grows great when old men plant trees whose shade they know they shall never sit in. This is an anonymous Greek proverb, and it kind of describes the politicians you want, the guys working for your children and for your grandchildren who aren't trying to get something for themselves. Unfortunately, the reality is the second quote from Thomas Sowell about politicians saying that their problems are really focused on getting elected and getting reelected, and everything else is very far behind. So who am I and why should you listen to me? So when I started my career, I spent 16 years as a consulting engineer, mainly in oil and gas, doing projects all over the world. I then was 16 years with a mid-sized oil company as a project manager and subject matter expert. The last 4 years, I've been a consultant to industry and have been developing long-duration energy storage for the electrical grid. Now, my career broke down into two main parts. One was leading large project teams. And when you're leading a large project team, the project has a goal. You're trying to build something, do something, and that has economic value. And because of that economic value, they've given you a budget. They've given you money. But they also have a schedule that they expect you to meet to maintain that economic value. So when people talk about think outside the box, I'm not wild about that term because to me, a project has a very clearly defined box. The purpose it's trying to achieve, the budget that it's been given, and the schedule you have to do it in. And if you get outside that box, you damage the economic value of the project. So you have to learn to play within the box, to compromise, to figure out better options and better alternatives. You've got to work within the box. The other part of my career, I was called on to investigate events. And this is called root cause analysis, where you're looking for the key thing that created the event and how to prevent those events from happening in the future. Now, the way to do this is you go in and you conduct an investigation. You dig up all the data. You do all the research. You figure out what happened. So when people say do your own research, that doesn't bother me because I have done research. I've been called upon to do these investigations. So how this got started. So in 2020, I was running a large offshore oil and gas project for the oil company. I got it through the worst of COVID, and then I realized I was burnt out. I'd worked for 32 years straight. I was tired. I was done. I quit my job and walked away. Before I could go back to the oil industry, I needed to answer a question for myself, and that was climate change. When you're in the industry, you're told that climate change is a hoax or that you're burning the planet down. Before I could go back, I needed to answer that question for myself because we're told what it is, but we're never given the data so we can make our own decision. So I decided to figure out and determine a way to prove whether climate change exists or not. Now, the National Weather Service keeps all the data from all the weather stations across the country. And one of those data points is what's called Tmax. It's the maximum temperature on the day at that weather station. So I figured out if I could get the Tmax average between 1901 to 1990, compare that to the Tmax average from 2011 to 2020, I would be able to see if climate change existed. So this is Brazoria County, Texas. The dots are the Tmax average for each year, and then the black line is the 10-year average. And you can see it's a very noisy signal. So taking the average across 1901 to 1990, I got 79.07 degrees Fahrenheit. And then from 2011 to 2020, I got 80.05 degrees Fahrenheit, which is about 1 degree of temperature change. Now, the years between 1990 and 2010 were left out to give us to give a gap so that we could see that number comparison easier. We could see the change better. So having done Brazoria, I decided I wanted to do another 24 counties at random. One of the counties was Galveston. When I did it, I got a much higher change in temperature. But Galveston is next to Brazoria, so that didn't make any sense. When I dug down into the data, I found that the 1930s were missing all the data from Galveston County. So I said, okay, I made some rules. For a year to be valid, it couldn't be missing more than 10 days of data. For a county to be valid, it couldn't be missing more than 13 years between 1901 and 1990. It had to have 77 years of valid data. So doing that, my 25 counties became 19. So here's the 19 counties. And as you can see, the numbers are all over the board. Now, some of this makes a little sense because like Terrebonne Parish is on the Gulf Coast and it's really half water with the amount of bayous, lakes, and swamps that it has. Some of the other counties in Missouri and Nebraska were actually impacted by the Dust Bowl events of the 1930s. They saw big heat waves in the 1930s. But still, we have a lot of variation here. So when you've got a data set with a lot of variation, what it usually means is there's some factor you're not accounting for that will make it make sense. So by working with the data a little bit more, I started to try to cross it with other references and see what I got. And when I brought in population density, the data started to make more sense. The urban areas where you've got more than 500 people per square mile, those are your cities, they all showed consistent climate change. The rural areas that were 500 to 100 people per square mile, they showed kind of a middle amount of climate change. And then the ultra-rural areas with less than 100 people per square mile, they showed no climate change or very little. So now, having found this pattern, I wanted to do 7 states, county by county, to see the overall picture in those 7 states. Here's the 7 states: California, Massachusetts, Texas, Ohio, Louisiana, Missouri, and Arkansas. And as you can see, again, we've got a big variation from California, Massachusetts at the top to Arkansas at the bottom showing cooling. Now, the column that says percent counties with years of data, that's how many counties within that state had valid amounts of data, the 77 years of data. And as you can see, Texas only had 16%. So I decided to open it up where I would look at counties that had more than 50 years of data from 1901 to 1990 to see if the numbers change, and the numbers didn't change by much. So I started to think about, okay, what's going on here? Is this just population density or is there something else? And I found there's something else. So when you look at gross domestic product, which is the gross domestic product that each state makes, that's kind of a measurement of their economy, and you divide that by the number of people in the state, you get these GDP per person numbers. And as you can see, California, Massachusetts have almost twice the GDP of Arkansas. So I think it has to do with gross domestic product, it has to do with the strength of the economy, it has to do with population density, but we are seeing a lot of variation here. So I sent the book to the publisher middle of 2023. I was a little worried about this section because nobody else was talking about this. But while the book was at the publisher, Wired Magazine published this article. And the question they're asking is, why was the central U.S. been so weirdly cool compared to the rest of the country? So I realized, okay, other people are also seeing this. I'm not off base. I'm onto something here. So the short answer is we are not burning the planet down. The red line is from a climate change advocacy group. The black line is the average raw National Weather Service data. I called this group up and I spoke with their director and I asked him, I said, look, my data is different from yours between 1900 to 1940s. Why this large difference? And he said it's because they had a filtering algorithm that was processing the data. I said, I'm an engineer. I understand filtering algorithms. Can I see it? No, it's proprietary. Well, I wasn't happy with that answer, and I also wasn't happy with the fact that the 1930s, when we knew we were having the Dust Bowl events and we were having these heat waves that were killing thousands and thousands of people, there was just too much variation. Now, if you go to my website, up at the top, there's a button called Data. If you press on that button, it will take you to this page. On this page are all the data tables that I used to write the book Fixing America, and part of it is the temperature change information. So you can go here, click on this, and you can look at the Excel data tables that I developed. I'm willing to show you my work. All right. While I don't think we're burning the planet down, we should be worried. There's a definite temperature increase that we're seeing. When you look at Brazoria County from 1901 to 1990, they had 78 days per year above 90 degrees Fahrenheit. From 2011 to 2023, they had 90 days above 90 degrees Fahrenheit. That's an extra 12 days of your air conditioner working harder and of having higher electric bills. The thing we need to understand is that from the 1960s till now, the world consumption of oil has tripled. We are burning a lot more fossil fuels now, and I think that is having an impact. But the other thing we need to realize is that impact is different from state to state. This is Arkansas, and that's California, the two extremes that we showed you earlier. Now with Arkansas, you can see that the 1930s heat waves, the Dust Bowl events, they hit Arkansas pretty hard. But right now, Arkansas is not seeing much presently. California, on the other hand, is seeing a definite increase in the last 20 years. So we've got to realize that when red states don't believe in climate change, it's partly because they're not seeing it like the blue states are. And the blue states are definitely seeing some climate change. So we got to realize that each state is seeing climate change differently. So I think we've been given a simple story, almost like a Hollywood movie. We've been told that the bad guys are the oil companies, that they're burning tons of CO2 and releasing lots of CO2 to the atmosphere. The good guys are the environmentalists, and they're going to save us by cutting back our fossil fuel usage. But that story's too simple. It misses a lot of the complexity. So I'm going to give you a slightly more complex equation for climate change. It's energy per person, CO2, heat, trash, everything per person, times the number of people equals climate change impact. Pretty simple. For the United States from 1960 to 2023, in 1960 we used 243 million BTUs per person. Now a BTU is a British thermal unit. That's a measurement of heat and energy. In 2023 we were 280 million BTUs per person, a 15% increase. It's actually doing pretty good for us because in 2000 we were 343 million BTUs per person. So we've come down to 280, but still it's a 15% increase from 1960. But when you look at population, in 1960 the United States was 179 million people. In 2023 we're 337 million, a 91% increase. So we've had a 120% increase in our climate change impact, and most of that has come from population increase. And you look at the world, it's even more dramatic. In 1960, the world average was 45 million BTUs per person. In 2023, it's 75 million BTUs per person. It's gone up 67%. We have to realize that Africa, India, China, they had very low energy usage lifestyles, which have increased in the last 60 years. But more so is the population. In 1960, we were 3 billion people. In 2023 now, we're 8 billion people. That's a 166% increase. So the world climate change impact has gone up by 344%, and most of that's being driven by population. So investigating climate change led me into a lot of other topics. I didn't set out to write a book, but eventually as I kept pulling in these issues and kept looking at them, I realized, and I simply told my wife, I said, this needs to be a book. So I'll leave you with these two quotes. The Baron de Montesquieu was a judge and political philosopher in France who wrote in the 1750s. He was a major influence on the founding fathers for them to write the Constitution. And the Baron wrote, "Political liberty is to be found only in moderate governments." 2 years ago, I wrote the second passage, which is, "A victory by a progressive urban faction or a conservative rural faction will not save America, but only increase the risk to our democracy. Our path out of this crisis does not exist in the hate or anger or in one side winning. It exists in having discussions between all Americans and finding solutions." Thank you very much. The book is, you can find the book at fixingamericathebook.com. There's a place on the website where it'll tell you where to buy the book. It's also available at Amazon. If you'd like, please follow me on Blue Sky, or you can follow me on Substack. Thank you very much.